Okay, guys, so far we've learned about the mole. We've learned how to convert from moles to particles and particles to moles. Yesterday, you learned how to calculate molar mass, which is the mass of 1 mole of any compound or atom. What we're going to learn how to do today is be able to calculate the mass of a certain number of moles of a substance or vice versa. All right, so here we go. And remember, you can pause this presentation at any point to copy down the note as well as to try the problems. So just like converting moles and particles, we have a nice little formula we can use. So converting moles in mass, we have the formula little n is equal to lowercase m over uppercase m, whereas n is the number of moles, lowercase m is the mass that you're given or that you're looking for, and uppercase m is the molar mass of that substance, which you learned how to calculate yesterday. So it's really important that you finish that lesson first. All right, so we're going to try some problems. So again, I'm going to be switching back and forth here. So please bear with me if I accidentally scroll ahead. Here we go. So in this question, it says calculate the mass of 3.5 moles of iron. So what we want to do here is list our givens. And so this is proper solution formatting, which we're going to have to be using all the time. So in this question, we're asked to calculate mass. Now, mass has the symbol of a lowercase m. And we're given 3.5 moles of iron. So we're given our lowercase n. We have 3.5 moles. And we know that our formula is n is equal to lowercase m over uppercase m. Sorry, I don't know why I did the whole line there, but so we're looking for, the one thing that we don't have for this formula is the molar mass, but we can easily either calculate that or look for it on the periodic table. So since we're just dealing with iron, all we need to do is look for the mass of iron on the periodic table, which is 0.85 grams per mole. All right, so again, we're looking for the mass, which means we need to isolate this one variable on one side of the equal sign so we can solve for it. Right now, the one thing that's getting in the way is this uppercase m, the molar mass. So we need to get rid of that. So because it's in the denominator, if we multiply that by an uppercase m in the numerator, we can cancel those out. But again, in math, what I do to one side of the equation, I have to do to the other. So here's our new formula. The mass is equal to the number of moles times the molar mass. So now all I need to do is substitute in what I know. So I know lowercase n is 3.5 moles. The molar mass is 55.85 grams per mole. My moles cancel out, which is great because I am looking for mass, and grams is the unit of mass. And if I calculate those, what I end up getting, oops, sorry, 1 second here. Just go back to that. Here we are. Is 195.48 grams. So we can say, therefore, the mass of iron is 195.48 grams. And there we go. All right, let's try another one. In this question here, it says calculate the number of moles in 5.67 grams of acetic acid. So again, we're going to list our givens. And we're looking for the number of moles. And again, moles has a symbol of a lowercase n. This time we're given a mass. We're given 5.67 grams of acetic acid. And again, we know our formula is lowercase n. The number of moles is equal to the mass divided by the molar mass. And again, the one thing we weren't given in this question is the molar mass. So that's one thing that we're going to have to calculate, is the molar mass of acetic acid. Well, I know acetic acid has the chemical formula, HC2 H3O2. So I just have to add up the masses of all of those atoms. So again, we can see here we've got 1, 2, 3, 4 hydrogens. And they each have a mass of 1.01 grams, which gives us a total of 4.04 grams. We've got 2 carbons. Carbon has a mass of 12.01 grams. And again, I'm getting all of these masses just from the periodic table. So we have 24.02 grams. And for oxygen, we've got 2 atoms of oxygen, and they each have a mass of 16, which gives us a total of 32 grams here. So if I add all these up, what I end up with is 60.06 grams per mole. All right, now I'm ready to go. So again, I'm looking for moles, so I don't need to rearrange this equation this time. Oops. So my mass again is 5.67 grams. My molar mass is 60.06 grams per mole. And if I divide these, I don't scroll ahead if I divide those. If I divide them, I end up with, 0.94 moles. So we can say, therefore, there are 0.94 moles of acetic acid. And it's that easy, folks. Okay, so if you are a little confused and need a little bit more practice, there's some supplementary reading on pages 235 to 238 in your textbook. And you can try the practice problems which are scattered throughout those pages. So try 41, 42, 46, 48, 50, and 51. And I have posted the solutions and the answers to all of those questions so you can try those. I believe I've also posted another worksheet that you can try in addition to that if you feel like you need some more practice. And the answers to those questions are also at the end of that worksheet. And hopefully we'll see you tomorrow. Take care.